Hello guys! As everyone knows, our solar system has a very flat shape, with the largest planets orbiting the Sun under almost the same plane. But why does this happen? Would it be a coincidence? Or would it be a consequence of astronomy laws? Welcome to our Wikivedia Plus channel. Let's analyze together and in more detail this problem. Eclipse plan. Some details about the ecliptic plane. The Earth revolves around the Sun. Any student of fundamental education who has attended classes without sleeping knows this. The Earth's orbital plane is called the ecliptic plane by specialists. Ecliptic literally means eclipse. It is so called because lunar and solar eclipses occur only when the Moon is close to the intersection of the Moon's orbit and the ecliptic plane. This does not occur with other planets, as the plane of their orbits around the Sun does not coincide exactly with the ecliptic plane. But they are very close to that. For example, Mercury's orbital plane is tilted 7 degrees in relation to the Earth's ecliptic plane. This is the greatest inclination among the planets of the solar system. Curiously, the planets are not the only ones in a plane close to the ecliptic. The asteroid belt and most of the trans-Neptunian objects are also in this plane. The planets of our solar system, in addition to being in the same plane, they orbit in the same direction of the Sun. It's a dance with incredible mathematical precision that has lasted billions of years. But when did this dance start? Why do planets get so aligned? Scientists have been asking about it for years. To find out why planets orbit almost in the same plane and in the same direction, specialists had to observe other stellar systems. Are other stellar systems equal to our solar system? Or is our solar system unique, and in other stellar systems, the planets move freely so that their orbital planes intersect? There is currently a lot of information about other stellar systems. Therefore, it is safe to say that most stellar systems are similar. In most stellar systems, the planets' orbital planes are usually aligned with the equator of the central star, and most planets orbit in the same direction. There are hardly any exceptions. As one of these rare exceptions is the Y Andromeda, a quadruple star about 44 light-years from the Sun. The biggest star in this united family is Y Andromeda A. 4 planets revolve around that star. After calculating the orbits of 2 of them, Y Andromeda C and D, specialists found that one of the planets was tilted about 30 degrees in relation to the other. The very rarity of this phenomenon speaks for itself, demonstrating to be a clear anomaly. It is possible that the Y Andromeda A companion star has affected the planet's orbit, causing it to deviate from its original orbit. Common stars usually do not have these problems. Aligning objects. Why do most planets in almost all stellar systems orbit in the same direction and almost in the same plane? Experts believe this is due to certain processes that occurred during the initial stages of the formation of the stellar system. It is known that stars and planets are formed in interstellar gas clouds. As an example, we have the Eagle Nebula, famous for the image of the pillars of creation. There are many possible reasons for the formation of the first mass in the rarefied gas. But this is not the main part. The heavier the mass, the more surrounding matter it attracts to itself. When the attracted matter joins it, its mass increases more and more. This mass is initially even thinner than the clouds of the Earth's atmosphere and has a symmetrical shape. But after accumulating and grouping enough material, it begins to disintegrate. That is, it begins the gravitational self-contraction. In general, this disintegration occurs where the matter is more abundant, that is, in the same plane. At the end of this process, it begins to obtain the shape of a flattened pancake, and that's what becomes a stellar system in the future. Most of the matter accumulates in the center of the pancake, forming a star. The remaining material will become part of the protoplanetary disk and will orbit the star. The reason why the direction of rotation always coincides with the direction of rotation of young stars is very simple. It's what they call angular moment. The young stellar system is still quite isolated. As other stars are very distant, it does not suffer any influence from young stellar systems. Within a closed stellar system, the angular moment remains constant, without change. This is one of the basic laws of physics. The material that makes up the protoplanetary disk does not move suddenly against the flow or in reverse rotation, because to do this, a great external force would be necessary. Pancake evolution. Therefore, it is not a nebula before us, but despite being a very young stellar system, it is well established. Although this stellar system is still in chaos, it is possible to see a glimpse of what it will be like in the future. The matter of this stellar system is in the same plane and rotates normally. But what happens after that? Then very similar processes begin to occur in the protoplanetary disk when the stars are formed. The dust particles that make up the protoplanetary disk collide and stick together, forming larger objects. And so the collisions continue, and the existing mass increases more and more, becoming a planet. The process of this system at this stage can be seen in images of HL Tower and its surroundings. This planet is still just a baby, less than 100,000 years old. This image is not a cross-section of a tree trunk made in Photoshop, and this is a young stellar system that is beginning to form. Note that all materials are grouped in the same plane. The dark gaps correspond to the planetary orbits. It is possible to observe that this planet cleans the trash, like dust and asteroids around it. Another young star with a protoplanetary disk is an orange dwarf, a class K star called TW Hydrae. This star is a little older than HL Tower, but still has its disk, as it has not yet collapsed. This disk can be seen with a high-precision telescope. A planet that does not follow the rules. Curiously, even a large celestial object, it cannot behave as expected. Some bodies refuse to orbit like others. In our solar system, there are no rebellious planets like these, but there are outside our solar system. As an example, we have ASP-17b, also known as Jitsu. It is speculated that this planet collided with a large object, causing it to change its direction of rotation. It is also possible that Jitsu was not formed near a host star, but was only captured by it. Similar cases are found in the solar system. For example, an asteroid that gets stuck in the gravitational field of a giant planet and becomes a satellite also orbits in the opposite direction of the rotation of the giant planet. These satellites are called retrograde or irregular satellites. There are other planets with progressive movements, but with highly inclined orbits. As an example, we have the Y Andromeda CID, presented earlier. Another of these objects is Pluto, known as the dwarf planet. Pluto's orbit has also intrigued many specialists. Probably the investigation of these strange behaviors should be carried out individually. Among the possible causes include the gravitational attraction of a larger planet or another star that is very close and is pushed by its gravity. Well folks, so we end our video today. Once again, thank you very much for watching to the end. I really hope you enjoyed this video, and I would like you to like and subscribe here on the channel. Also, do not forget to share on your social networks. Your collaboration is very important for our development. And it's time for us to say goodbye. But I hope to see you again soon here on the Wikivedia Plus channel. A big hug and see you there.